Myself, Impana MG, studying in Sri Venkateswara College of Engineering. Today I am going to talk about multiplicative group of integers, Modulo-p, and permutations group. Introduction to groups. A group is a set of equivalent with a binary operation satisfying certain axioms. In mathematics, groups are fundamental structures used in various fields. Understanding different types of groups, such as multiplicative and permutations group, is essential. A group consists of a set and a binary operation. A group has the following four axioms: closure, associative, identity. Overview of modulo p. Modulo p refers to the operation of finding the remainder of division by a prime number p. This concept is crucial in number theory and cryptography. The integers modulo p form an infinite set that can be analyzed using group theory. Definition of the multiplicative group. The multiplicative group of integers modulo p consists of the integers 1, 2, 3, so on till p minus 1. These integers are considered with respect to multiplication modulo p. The group is denoted as shown. Properties of the multiplicative group. It has an order of p minus 1, which is the number of elements in the group. Generators of the group. A generator of a cyclic group is an element that can produce all other elements through its powers. If G is a generator, then G of K for K is equals to 0, 1, so on till P minus 2 produces all elements. Order of elements. The order of an element in a group is the smallest positive integer n such that G of n mod p. Different elements may have different orders, which can influence the structure of the group. Knowing the orders can help in understanding the group's properties and subgroups. Subgroups of the multiplicative group. Subgroup are subsets of a group that also satisfy group properties. The multiplicative group modulo P has several subgroups of all which are cyclic. The order of any subgroup must divide the order of the group P minus 1 according to the Lagrange theorem. Applications of multiplicative groups. These groups are widely used in cryptography, particularly in public key cryptosystems. They serve as the backbone of the algorithm that on the difficulty of factoring large primes. Understanding the structures aids in developing secure communication methods. Introduction to permutation group. Permutation group is a group whose elements are permutation of a set. The group operation is the composition of permutation. Permutation groups are fundamental in the study of symmetry and combinatorial structures. Symmetric groups. Symmetric group consists of all possible permutations of n elements. It has an order of n factorial, reflecting the number of ways to arrange n distinct objects. Symmetric groups demonstrate a rich structure and have many interesting properties. Cyclic notation in permutations. Permutations can be represented in cyclic notations, which highlights the orbits of elements. For example, the permutations 1, 3, 2 repeats a cycle where 1 goes to 3, 3 goes to 2, and 2 goes back to 1. Understanding cyclic notation is essential for working the permutations group. To find the number of permutations of n times, choosing r at a time, you can use the formula for finding p of n r or npr. npr is equals to n factorial divided by n minus r factorial, where 0 is less than or equal to r, less than or equal to n. Properties of permutation groups. Every permutation group is closed number composition and includes the identity permutation. The inverse of a permutation is also a permutation within the group. These properties ensure that permutation groups are integral groups as defined in abstract algebra. Applications of permutation group. Permutations group are used in combinatorial designs, coding theory, and algebraic geometry. They model symmetries in algebraic structures and geometric figures. Understanding permutation groups facilitates the analysis of complex systems. Relation between groups. The multiplicative group and permutation groups has interconnections in algebra. For instance, the automorphism group of a multiplicative group can be permutation group. Studying these relationships enhance our understanding of group theory as whole. An isomorphism between two groups indicates a structural similarity. If two groups are isomorphism, they share properties and behaviors despite being defined differently. Exploring isomorphisms helps in classifying groups and understanding their equivalence. The fundamental theorem of finite abelian groups. The theorem states that every finite group can be expressed as a direct product of cyclic group. It provides a framework for analyzing the structure of groups. Computational aspects. Algorithms for group operations are crucial for partial application in computer science. Efficient computations in multiplicative groups Modulo-p is essential for cryptography. Understanding the computational complexity of a group can guide algorithm designs. Challenges and open problems. Despite the established knowledge, there are still unresolved questions in a group theory. Research continues into the complexities of group and their applications in various fields. Exploring these challenges can lead to new discoveries and advancements in maths. Conclusion. The multiplicative group of integers modulo p and permutation groups play crucial roles in mathematics. These structures, properties, and applications are foundational for understanding algebra. Continued exploration in these areas can hold significant contribution to both theoretical and applied maths. Thank you.